Okay, so now here in part 2, we're going to move on to a couple of applications. What's one of the biggest applications that we just saw at the beginning of this lesson, and that is money! Woo! We all love money, so this is a good thing. What exactly are we talking about? We're talking about compound interest. So we need to know our compound interest formulas. So compound interest with n compounds per year is A equals P times the quantity 1 plus R over n to the nt. Okay, great. What does all of this mean? So let's start with P. Sorry. So P is going to be what we call the principal value. An easy way to think of that is the starting value. So if you're investing money, how much are you investing? R is the interest rate. So if you have a 4% interest rate, R would be 0.04. N is the number of compounds per year. Well, what's a compound? The compound is how often, for instance, the bank is actually calculating the interest that you earned. So that could be like semi-annually. It would mean that they're doing it twice a year. Quarterly would be 4 times a year. Monthly, 12 times a year. Daily, 365 times a year, and so on. As n grows, though, n can become infinity. And so that's what we call compounding continuously. So I'm going to talk about that in a second, but let me finish with these variables. So T is time, and then A is your ending value. So how much do you have after some time T? And so if you have this information, you can plug these values into that equation. So then what I was talking about is we have another equation as well, and that is A equals P e to the RT. So you may have seen this before or seen or heard PERT. This is for compounded continuously. Well, it's not possible to physically compound continuously, but it's an idea of a limit again, and it has to do with the definition of E. So remember, back here we can see a limit as n goes to infinity. That's one of the ways in which we can come up with E, and so that's why E is in this equation. Once we understand calculus, I can show this to you better. But for now, you're just going to have to trust me that for compounding continuously, we use A equals PE to the RT. For any other amount of compounds per year, then we're going to use this equation. So you need to know both of those equations. So let's do an example. Okay, so if you're given $10,000 is invested at an interest rate of 3.2%, find the balance of an account after 10 years. If it is compounded quarterly, and then if it is compounded continuously. So pause the video, find each of those, and then unpause when you're ready to check your work. Okay, so in green, I'm showing the work for quarterly, so I have $10,000 invested. Here, my interest rate is 0.032. It's compounded quarterly, so that is 4 compounds per year for 10 years. If I type this into my calculator exactly as that's written, except for if you want to do it exactly, you probably want to put parentheses around that. I end up with $13,753.76. So if I invest $10,000 for 10 years at 3.2% interest, after 10 years, that $10,000 will become $13,753.76. So that's pretty nice. One thing to point out, just a notation thing, whenever you're talking about dollars, then it's okay to round to 2 decimal places. I know I mentioned before, things should always be rounded to at least 3 decimal places, unless otherwise specified, but with dollars, you can round to 2 decimal places. If we compound continuously, that's here in the blue, so 10,000 e to the 0.032 times 10. If I type that into my calculator correctly, I get $13,771.28. So you can see that in general, the more compounds you have, the more money it's going to make. But it's not necessarily a terribly significant amount. Over the long run, it may be, if you were doing over 100 years and the initial investment was a lot more, or if the interest rate was higher, there's other ways you can fluctuate or play with this. But in this case, is less than $20 more over the 10 years. All right, so last example. So here's a half-life problem. So this is going to be exponential decay. So let Q represent a mass in grams of radioactive radium, which is Ra226, whose half-life is 1,599 years. The quantity of radium present after T years is given by this equation. Find the initial quantity, find the quantity after 1,000 years, and then find when the quantity will be 0 grams. One thing to point out, so you don't necessarily need this for this equation, but in general, our generic half-life equation is n equals n sub 0 times e to the kt. So this is actually the exact same thing as the PERT equation, just you're using different variables. So n is the amount you have after some amount of time, n sub 0 is the initial amount, e is our base, k is some constant, so that's like your interest rate, and t is the time in years. So again, now pause the video, find these three things, unpause when you're ready to check your work. Okay, so hopefully you figured out the initial quantity is going to be when t is 0. So if I plug in 0 for t, the entire exponential part just goes to 1, so Q is 25, and I should have said grams. And the quantity after 1,000 years. Plug in 1,000 for t. Type this into my calculator correctly, and I get 16.206 grams. And when is the quantity going to be 0 grams? That is going to be never. This is an exponential function, so it has that horizontal asymptote of y equals 0. It's never going to reach 0. It'll become infinitely close, but it'll never get there. Okay, so conclusion about exponential functions, we want to understand what an exponential function looks like. So it has some base that is a constant raised to a variable, in this case x. That base has to be greater than 0 but not equal to 1. X can be any real number. If the base is e, then that's what we call the natural exponential function. Exponential growth is when things are increasing at an increasing rate. Exponential decay is when things are decreasing at a decreasing rate. And then we want to know our compound interest formulas. A equals P times 1 plus R over N to the NT is when we have N compounds per year. Compounded continuously is A equals PE to the RT. That's it.